Hello and welcome to this virtual safety training session. We're going to talk today about step and touch potential. In electrical safety, we always need to remember rule number one. Electricity is always going to go to ground, taking the path of least resistance. And we want to make sure that we don't become part of that path. If we look how the electrical system is set up, it's set up pretty much like our architecture in telecommunications. We have our transmission lines, which is our fiber optics, our distribution lines, and then finally a service drop running to the home. The difference here is that in our systems on telecommunications, we normally don't run into voltages over 90 volts. But if we look at the electrical system, they can carry anywhere from 120 to 750,000 volts. It's pretty easy to see that at these voltage levels, it can be very dangerous. At the higher ends of the scale, the voltage and current could be catastrophic. Now, here's a dangerous situation, indirect contact. Now, electrocution can occur when a path to ground is created by our bodies. We see here that the tree's leaning up against the power lines. They're energized. That tree becomes energized. We walk up, we touch that tree. Now we become a separate path for that current to travel to ground. Now, because our bodies have a resistance, the path taken by the current is going to heat up our body and burn the tissue inside of us, kind of like a toaster. The wires inside the toaster are resistance. The current runs by that. Everything heats up. So we don't want to get toasted. Now, once it's made its way through our body, the current is going to leave violently, and it's going to happen at the point of contact where we're in contact with the ground, which is usually our feet or our legs, and it will leave an exit wound. Now that we understand why power lines are so dangerous, let's talk about how and why power line contacts occur and what we can do to work safely around them. You see here we have our safety gear, our hot gloves with our overglove protectors, and our hard hat. Both these pieces of equipment are rated for 17,000 volts of AC. And also we do have for the underground folks, the locators, the tracers, trackers, the operator, dielectric boots to help protect them. The leading cause of power line contact involves heavy equipment and workers' tools. On the job site, we need to make sure that we have proper clearance for our equipment, whether it's an excavator or a bucket truck. We always try to maintain at least 24 inches of clearance. Common causes for coming in contact with electrical lines could be long-handled tools. You need to be careful when you're potholing. Again, you should dig towards the locate marks. Don't dig straight down on the locate marks. Also be careful with ladders. Yes, our ladders are made out of fiberglass, but we can still pick up an induced voltage. And again, we still have to worry about making contact with power lines. Look at these three people moving the scaffold down below. They're trying to be careful, but just a little bit of a wiggle, a little bit of piece of wind blows it into the power line, and these three guys are knocked out. Always, 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 before drilling, before digging, make sure that all the utilities have been called in to misdig. Everything's been located. We can see the flags, we can see the paint. We want to make sure that we're going to be clear of the electric, gas, communication lines, water, and sewer. So again, we want to expose these utilities. If we're going to go below the utilities, we want to dig down below them at the depth we're going to cross. We want to have eyeballs. We want to see that drill head passing as it goes forward, and we also want to see it have eyeballs on it on the pullback. Let's talk about step and touch potential. We can see that this high tension power tower has a fault. So in one case, you can see that it's going to ground. Well, that ground becomes energized. If we look at the person on the right, his legs are very far apart, and the leg closest to the tower is going to be at a higher saturation point than the foot on the other side. It's going to be a lower point. Now we become the path for ground. If we take a look at the person at that center picture, he's actually making contact with that tower. In this case, yes, it's already grounded, but now he becomes an auxiliary path. He's another way for that current to go at a little bit lower resistance. It's the ground under his feet are not as saturated, so he gets shocked. So if we remember rule number one, that current's always going to flow from a higher concentration to a lower concentration, this is pretty easy to understand. Step potential. We have a break on the left side where we have X amount of voltage and current, and it dissipates, it gets lower, it's attenuated as we go further down the line. So again, if we are at one point is at a higher level of concentration and our other leg is at a lower one, well, now we become the path to ground for that current. Same thing with touch potential. In this case, something's already energized. We come up and touch it. Again, we become an alternate path for that current to dissipate to ground. So be careful. This is a good example of why they tell everybody to stay 20 to 30 feet away from a down power line. That power line, the ground it's on, is going to become highly saturated. And you'll notice as it gets further away that the voltage drops. And in this case, unfortunately, the person is walking towards that line. And he's at 14 kV with his back leg, but when he steps forward, he's in the 16 kV area. So of course, that 16 kV is going to try to find a lower density, and it's going to go back to the 14 kV. Dielectric protection. Now, the dielectric boots can protect you from both direct and step potential. If we look over to the right there, you see the person making direct contact with the energized line. And also he's in direct contact with the ground. You can see the path it takes. Now, if somebody's on a line that's hot, do not touch them. You know, don't do it. Find a dielectric object to free them. Now, this is why underground operators and locators should have overboots. If the drill head strikes a line, it's going to energize that ground right below that person that's locating. Also, it's going to travel down the rod back to the drill itself. Now, on the aerial side, we want our people to be wearing hot gloves when they're pulling strand till it's been tied off, tensioned, and attached to the power company's multi-ground neutral. Okay? And talking about the gloves, operators are supposed to have a pair of gloves on the rig with them just in case. Now, if somebody is in contact with an energized source, do not touch the victim until the power source has been shut off. And also be careful of wet areas. Water is going to be a good conductor for that current. Now, if you can't turn the power off, you can try to dislodge the victim or the live wire with a non-conductive object. Your hot gloves, a layup stick, a rubber floor mat will help. Now, if you have any questions, please contact me or your supervisor. And everybody, please stay safe.